Welcome to the physics video lecture. Once again, here we are. It is Psci 168 video lecture 22. So I brought some stuff back on the table again. We had done a review last time because there's an exam coming up. So I may mention a thing or two about that. Let's see what's on our plate here. The exam review was on the previous lecture, so C lecture 21. Okay, so that was our exam review. But we are now in thermal physics, and I'll do a little bit of a review on thermal physics, and then I'll do an interesting demonstration for you. I just brought these things to remind us that we had talked about them some time ago. So for thermal physics, we start out from scratch. That is to say, we start out with just the basic sensation of hot and cold. Okay, so we have hot / cold sensations. That's where it starts. And then we find that we can associate, of course we already knew that, but we can associate things with heat and cold. Still didn't bring the bucket of ice along, but you can imagine I have a bucket of ice right here. And of course we have the flame from the torch. Okay, that thing's real. So flame on the one hand and ice on the other. Then in addition to that, we have some phenomena, namely thermal expansion phenomena. So the next thing was thermal expansion. So if you soak things in a flame, they actually expand. I showed you that. And then the next demonstration was this bimetallic strip. So we now know that it'll bend. I hold it in the flame, there we go. The reason it bends, let's have it bend that way, okay, turn it around. The reason it bends is because it's a sandwich of two different materials, two different metals, one of which expands more than the other, okay? Pushes it around like that. And then remember we said we could put it up here and have a scale and call it a thermometer. So thermal expansion takes us right to thermometers, and then we're able to invent temperature scales. Now, there are other phenomena as well. When we're talking about the temperature scale, we make use of the thermal expansion, but we tie the temperature scale to some common phenomena, for example, water boiling, ice melting, okay? So we get those temperature scales, and we had degrees Celsius, well, degrees Fahrenheit, degrees Celsius, and the third scale that I introduced kind of with a discussion of this gas thermometer here was the Kelvin scale. Okay, so Fahrenheit, Celsius, Kelvin. And we had temperature scale conversions that, you can look them up. The Celsius scale is the one we're going to use in our physics formulas, because everything we've done with kilograms, meters, seconds, and when we talk about temperature, the degrees Celsius scale will fit right in. The Kelvin scale has the same increments as the Celsius scale, but it starts at 0. It's all right here. T in Kelvin is equal to T in degrees Celsius plus 273. So that absolute 0, of course, is very important. I think that's pretty much what I ended with the other day, talking about absolute 0, when all motion ceases. Good. So what would we have next on our agenda? Two things. The tie-in to energy. What's the relation to energy? So let's just put this here as questions. Question, what is the relation of what we have here to energy? So how do these things relate to energy? Thermophysics and energy. Right now it's just a question mark. It's two question marks. And we'll answer that. Before we answer that, well, actually I can give a little hint. We already saw something here. Remember the demonstration where, can I even do that with body temperature? That's right, I can. See, I'm heating the air in this flask, and well, let's not be too impatient. How about we take the torch? We'll heat the air in the flask. There we go. So we're getting a column of water or fluid that goes up there. You could have actually said the same thing with this thermometer, where a very thin column of fluid moves up, okay? Because you could say, well, if something's being lifted, there's a little work involved, okay? And the same thing with that column of liquid there. But so there's a hint of work right there. Remember, energy is the capacity to do work, and we'll return to that. Okay? But for the moment, the question is not fully answered. So the next thing I'm going to do is talk about calories. Calories, okay. And I'm going to do this with a demonstration. Now, what's my demonstration? This is all one take, no edit, so wish me luck. Yeah, so I brought a piece of butter to class. Butter, okay. And as you know, all these food items have the label that tells you about the calories and stuff. Maybe I'll hold it up to the camera just to remind you. There we go. So what did that say? It says 100 calories, 32 servings. This is a box of butter that holds 1 pound. Okay. So we have 100 calories for 1/2 of an ounce of butter. So what is a calorie? This definitely exemplifies calories. So here's the butter. And what I'm going to do is make a candle with the butter. So I have some cotton string here. I hope this is the same thing it was last time I tried it. You have to use cotton string to make a wick for a candle. Here's my piece of butter. So I'm going to unwrap this thing. There we go. We're going to just push a piece of string into this piece of butter that's been in the refrigerator. So we just saw it in there. Okay. And I can even close it up a bit now that it's in there. It's like a cooking show. Okay. So now I have a piece of butter with a piece of string coming out the end. And I'll do a little trimming. Gotta get some scissors, hold on. Good, we're back with the scissors. So I'm going to cut this wick like so. These scissors that even cut? Yes, they do. Okay, cut the wick. Hold this on about like that. Now it's time to turn this into a candle. So we will put the candle right here. Okay, usually you don't light your candles with a blowtorch, but that's what we have going on today. There we go. So this is a nice healthy candle. It is burning. I'm going to hold it up to the camera. Stick of butter. How about that? Okay, so this butter has calories, and now that butter is burning. Now this is just my mock-up, you could say, for, oops, is this gonna work? For my cartoon. Okay, so this is just the idea. Now the idea is that I would apply that flame to a beaker full of water, and my beaker full of water here would have a thermometer in it. This is gonna be our cartoon. For the rest of the semester, we'll draw square candles, okay? Kid you not. Okay. And like I said, this is just the idea. There's water in here. The heat from the candle raises the temperature of the water. And that will bring us to the definition of the calorie. See what that looks like. Could be better, but that's the only stand we have back here, at least right now. Okay, so the butter is burning. The reason you need a cotton wick is if you use any kind of nylon string, it'll just melt. Okay, so that's a cotton string. Got a beautiful candle here. That butter's not going to go to waste. I'm going to blow out the candle and use it later on. But I have to now tell you what is a calorie. Okay, so let's extinguish this and take this back down. We'll leave the butter candle there for the duration. So demonstration butter candle. Let's get some room on the board here. Butter candle. Okay, so let's get this open right here. Yeah, this cartoon, namely I'm just going to draw a picture of that, will help you remember what's going on here. So we have our candle. Okay, there's the wick. Here's a stand. Here's a beaker with water in it. We've got colors, and we have a thermometer in here. Okay. We'll even measuring in degrees Celsius. How about a red flame? Okay. So this was our demonstration. We've got butter, flame, water in here, temperature's increasing, and what is the definition of a calorie? The definition of a calorie is, I'll write it here. Calorie, it's the amount of thermal energy, we call it heat right now, that will raise the temperature of 1 kilogram of water by 1 degree Celsius. Okay. Calorie. We're going to call it heat raise the temperature, this is the crucial part, of water, 1 kilogram of water, 1 kilogram of water by 1 degree Celsius. That's a calorie. Now notice, I wrote it with a capital C, and in fact, if you read it, and if the producers of this stuff get it right, they also write it with a capital C. So the calorie with a lowercase c is 1/1000th of one of these, so it would heat the temperature of 1 gram of water by 1 degree Celsius. Calorie equals 1/1000th of a calorie. This is also referred to as the kilocalorie, so you may run into that. So 1 calorie equals 1 kilocalorie. Okay? I like to start with the capital C calorie because that's the actual food calorie. Okay? This is the calorie that we're thinking of when we eat food. And so now we learned what a calorie is, and this holds true for all food. Food items will be carefully dried out and then carefully burned and be used to carefully raise the temperature of a certain amount of water, and that's how the caloric content is determined. So for example, this stick of butter, since it's a quarter of these 3,200 calories, it has 800 kilocalories. 1 stick of butter, quarter pound, 800 kilocalories. So what about lettuce? Lettuce is almost all water, a little bit of fiber, so if you dry the lettuce completely, you can grind it, powder it, make it into a little powder and burn it, and it'll just deliver a couple of calories, okay? A whole head of lettuce, maybe a few calories. Stick of butter, 800 calories. So how about homework project? This is one you guys should do. Make a butter candle. Make a butter candle, take a picture, print it out, put it in your notes. That'll be fun. And the very important note here is you have to have a cotton wick. If your string is nylon, it'll just burn and melt. Okay, so you have to have a cotton wick. And while we're on the subject, we can kind of discuss what's going on there. So because there's some physics there that'll come into play later as well. The wick is soaked in butter, and when I apply a flame to it, butter gets so hot it vaporizes. So the butter vaporizes up in the top of the wick and the flame, and then the fuel, butter is just oil, fuel combusts. Okay. So you can do the same thing, by the way, with oil. If you have a dish of some kind of cooking oil and you put a wick in it so that some of it sticks out above the oil, you can get that to burn as well. So all these things, be careful, do it, do it in the kitchen under the hood. But this is a fun one. For example, you can imagine having a cake with butter frosting and then have a bunch of little wicks in there, and try that maybe. Birthday cake with butter candles. So that's a homework project. Pictures or it didn't happen, right? Butter candle note, cotton wick. So we've got the calorie, and yeah, I'll just add a little bit now to that. We'll leave that picture up. So the caloric content of foods is literally how much fuel is in there, and you can measure that by burning it and seeing how the temperature of water increases. Okay, no more, no less. Let's put a little list up here. These are the common numbers. You could look up and make a little table if you go online and look up some more values, but let's call this heat of combustion, since that's what I just described, burning something. So heat of combustion, there are 4 foods, well, 3 foods. We talk about fat, protein, carbohydrate, and we could put alcohol here as well. These are things with well-known caloric content. So heat, and that's the heat of combustion. So for fat, we have 9 calories per gram. Okay, put it in words: 9 calories per gram. And then for proteins, it's about 4. Carbohydrates, it's about 4. And alcohol, it's about 7. Now the interesting thing about this is pretty much the range, the rough range for all fuels. So if you were to try to find out what's the heat of combustion for gasoline, okay, gasoline, it would be maybe 10 calories per gram. All oils, olive oil and so forth, 9 calories per gram. So this 9, which we can round up to 10 if we're just talking on general principles, is a really basic number for the heat of combustion for fuels, okay, fuels, and as we'll see later, just for chemical energy in general, okay, 9 calories per gram. There are going to be some transformations. We're not there yet though, because we're going to turn this into our standard energy units. But for now, it's good to learn about it in this way. And you could extend this table if you want. You can look these things up and you know, extend it a bit, possibly get some more accurate values for different types of fuels. These are all fuels in this sense. But what's good about this is all we have to memorize. 9, we can even round up to 10, and then we know what heat of combustion for fuel. So fuels are all similar. So we'll talk later about coal and natural gas and this, that, and the other. It's all roughly these amounts here. Okay, so that's a good thing. It all just reduces to burning something and measuring the change in temperature of a given amount of water. And since we had that definition, it's down now. 1 calorie, 1 kilogram of water, 1 degree Celsius. Good. That's probably what we're just going to leave it with today. Yeah, we don't have to do much more today. We've got that that exam coming up. This material is not on the exam, right? The review that I did on lecture 21 ended with hydropower and just general energy discussion. But this is our current and next major topic, all about thermal physics. And what we learned about today was heat of combustion, the calorie, the butter candle, and we'll leave it at that. See you guys next time.